Right Track Motoring, your online showcase for everything in the world of motoring.
When you see the car, first of all, the design already gives you a certain expectation.
From a physical standpoint of view, we have a very low center of gravity.
It has 400 horsepower, goes 125 miles an hour.
It's a huge amount of torque. When you press down the accelerator, you're going to feel this instant response. You get pushed back in the seat. To feel this quite large vehicle move so fast in complete silence is very dramatic. Well, what is impossible?
People told us at the beginning it can't be done. When you go a little bit deeper and you ask yourself what is actually possible, what is impossible, we heard the same question. If it's so easy, why did nobody else do it?
Bill Talley, Director of Vehicle Integration at Fisker Automotive, took the podium at the Motor Press Guild in Los Angeles, where he introduced the 2012 Fisker Karma. After his presentation, limited test drives were available to the MPG members. Let's listen to some of his comments.
This gives us a little bit of idea of the timeline and how rapid our progress has been. We're very entrepreneurial based. All the people at our company really do have the driving passion, and we've learned how to go through, get the cars done, designed, and into the customer hands rather quickly. We started off in 2007 with the original concepts, with the first cars driving actually in 2009, and then with the outset of getting our funding in September, we went from there all the way to customer deliveries in under 48 months, which is an astounding feat. Now, one of the things that we're going to go through here is that since we are so design-driven from our styling element, is Henrik's big goal and philosophy on this was we were going to give a car that, when we showed the concept, a lot of the cars that when they come to the next stage, they don't really look like what was on that stage. So Henrik's deal was it was going to be the same car, one way or another. And full 22-inch wheels, all the other aspects of the car with the big hip lines and all the rest, which can give a lot of the engineers a little bit of fits as you're trying to package as much equipment as we are into these vehicles. But that was really our design philosophy. The passion had to be in the vehicle, and we really tried to drive that all the way through. That led us to some challenges. Now right here you can see the vehicle and some of our performance statistics. We've got good range. We're at 300-mile range with a combination of EV and gas, so you can use it like a normal vehicle every day. But we also have good performance with 403 horsepower and a tremendous amount of torque. We have over 950 foot-pounds. So the vehicle, there's no downshifting, there's no clutch, no transmission. It's one speed from 0 to 125. So it makes for a seamless drive. The other big thing that we are able to do is we're really getting into the fuel economy areas now. If you look at some of the, between the European and the US numbers, they change a little bit on how they rate them. But right now in Europe, we're at 2.4 liters per 100. So we're at an unheard of number. Our CO2 in Europe is 53 grams, which we're getting into ranges now, which are almost pure EV. And that was doing testing, with the engine on. So as being able to do our combination of electric and gas power, we're able to drive a very, very good range. And the other thing it allows us to do is that we do have still a vehicle that can be considered a pure EV in the cities. The US cities will, I'm sure, go to it here soon, but in Europe, you're getting a lot of the city centers where you're not allowed to drive a gas vehicle without a lot of permits and taxes. This vehicle can go in as a pure EV. It stays EV when you're driving it in stealth mode. You have 50 miles of range, so you get into the city center, you can run it like a normal EV. The taxes are zero, and it's made a really big advantage, especially in Europe. Give you a little bit of idea. This is basically what my end of the company does. I'm in charge of vehicle integration. So we do all of certification and homologation worldwide and all of safety compliance. We're also in charge of all the vehicle development and testing. So we run as full vehicle level. We do all testing, all durability testing, all emissions testing, pretty much everything that has to do with the full vehicle. We're also in charge of all safety system design. So we do all the restraint systems, all the airbags, all crash testing, and all that falls under vehicle integration. My department also runs all the CAE and CFD work. So we're really involved with the vehicle from the very first concepts until you get it out into the public hands. And one of the things on the CAE and CFD, which I'll show you in a little bit, is when we did the vehicle with Fisker is we didn't have a lot of time. We wanted to make sure we hit it right the first time. We're not a large company, so we didn't have 200 cars to go crash and figure out on how your airbags were going to work. So we did much of our design all in CAE and on the computer. And we worked really, really hard to make sure we had good models that correlated and everything else so that when we did go into our airbag testing, we did it with a minimal amount. It's still 30 cars, but it's not 200. And it was one of the things that led us to be able to get into the market as quickly as we did. You know, we had to design the car as a global platform, which is another big item that a lot of people have not been able to hit right off the bat. I mean, literally within a few months of us having full US cert, we have full European type approval, which is kind of unheard of because the rules are drastically different on some of the crash aspects and emissions aspects. We do all the dimensional management, the functional integrity, all the NVH. Virtually everything that touches the whole car runs through vehicle integration. Give you a little bit of an idea of some of our challenges we had is, you know, once again, we're a design-driven company. So the car's low, it's sleek, it's got a large hip line, it's got 22-inch wheels that you have to make fit inside wheel wells, and you have to make turn and get a good turning radius. So as you can see, there's a lot to package in an EV. This kind of gives you an idea with some of the silhouette of the body on it. And here is just the powertrain. There's a lot in an electric vehicle. Basically, you have all the powertrain of a normal car, and then you put it in an electric powertrain. So we have, you know, this is, towards me is the rear of the car. So we have all our traction drives. We have 2 inverters in the back that had to be packaged, the large battery that fits down the center, and then the ICE, actually the combustion engine with the genset package. Now, one thing we like to note is that we are a true series hybrid, so we have no mechanical hookups to the rear wheels. The only hookups we have is through our traction motors, through electric drive. So all our drive is pure electric. So that's where we were the first series hybrid to hit. Unfortunately, that cost us a little bit of grief and aggravation as we went through all the different agencies throughout the world because they didn't know how to test us because we were the first one, and it changed a lot of the ways on how they wanted to run the vehicle. But it gives you a little bit of an idea on how much there is involved in this hybrid. Now, another huge aspect that we did that was a challenge because we wanted to make sure we had a flat floor and we didn't get anything to really intrude into the foot line or anything is we have a front exhaust. And a front exhaust is a big challenge. You don't have a lot of volume, you don't have a lot of room to package it, and our team did a fabulous job of getting something that works very, very well. We did quite a bit of CFD and CAE testing before we were ever finished. And we were able to take the models, generate, and get our bodies to where we didn't have to make a lot of different iterations of our stampings, which was a big time and money savings. This shows you the differences. This is our early CAE models on top, and then with the actual crash tests on the bottom. You don't get quite the dramatic of the glass exploding and everything as you do in the animation, but it gives you a little bit of idea of how closely our models were able to correlate. And from these models, we were able to go through and figure out some of our initial airbag pulses, how we were setting up airbags, just what all our frame deformation was going to be, where we're going to intrude on any of the different areas into the cockpit or anything else. And it really took us and saved us a good 8 months of testing. And it was really amazing on just what we were able to do. Now the next one really is probably one of the biggest hits we do, which is the 50-mile-an-hour rear. And the same thing, you can see just how well we were able to correlate all our data, and also how strong the vehicle is. The vehicle takes a full hit in the back. It doesn't even break the rear glass. All the doors still open. It really is an amazing structural vehicle. Now, doing this type work is one of the things that we correlated into our next programs also. But it really was able to, is where we kind of drove some of the industry standards on how we were able to do this and what we were able to do for both the US and global, because the crash standards are different. And so we were able to keep this and do a lot of this design without destroying a lot of cars or waiting till we had the cars built. And this was a huge, huge milestone in what we were able to do. So this kind of gives you a little bit of idea on some of the other items we've done with Fisker. You can see one big item is we have a solar roof. And while the solar roof a lot of people don't think is very much, it puts out about 120 watts, but it adds a tremendous amount of range to the vehicle, especially over the year. We're able to keep all our 12-volt systems completely charged up with it. We don't have an alternator on the vehicle. And without the alternator, basically you're taking all your voltage off the high voltage battery. And because of that, we really wanted to make sure, once again, in Henrik's philosophy, we really tried to keep no compromises on the vehicle. So we went to this solar panel. It's the largest curved piece of solar glass there is. It's a large, complicated part, but it works quite well. And it adds a lot of range to the vehicle, and it was also once again, it's part of the style and design element that, that Henrik drove into the company. It's been able to keep the car, it keeps it cool on the summer months. Once the battery's charged up, turns on your fans inside. So at that time, you're recirculating some of the air. It doesn't turn on the air conditioning, but it does turn on all the recirculating fans. So since at that time, you don't have to turn the AC on as much. So we tried to look at all the different items that would get us a little bit more efficiency and keep us in a green economy. So far as as we've been getting through this between Europe and the U.S., the European markets with the taxation rates that they have, which is on mainly your CO2 footprint, the car is going over tremendously. We have in most of the countries we have virtually zero tax. Where like in the Netherlands, a comparable car like a Panamera is almost $10,000 a year in taxes because of its CO2 footprint. And we missed it by 3 kilograms to have zero, but we have we have the smallest tax you can actually have, with a gas car. So that's made a big difference, and that's a lot of the areas throughout Europe. We think we'll see some of those same type tax rates and same type other items start to come into other areas throughout the world. I think some of the city centers in the United States are going to start hitting this, and it's really made it to where we have a global car. And that was the other big aspect of what Fisker was. Fisker was designed as a global company. We're not just building an American car. We're not just building a European car. We're building a car to go around the world. And I think the team has been able to do a phenomenal job on what they've done. We do have some cars in the parking lot. I think some of you guys have seen them as you came in. We are going to set some of the other stuff. Russell and everything will set up some of the things on getting people in some of these vehicles. We have engineers out there also. I'm open to any technical questions. I'm the engineering side, so any of the other side, that's to Russell and Roger. But any of the other technical questions or anything, feel free to ask.
Fisker Automotive will always create vehicles that are desirable.
The passion that we have,
The passion that you're going to have.
pure driving passion. We are a company of believers.
Tune in for another episode of Right Track Motoring.